This house is gum when I have it.
Okay, Donald, we are gonna start 7-4 instead of trying to compare our backpacks. Um, So this whole section involves the K that was in that problem 5 on the homework from yesterday. I think that was yesterday. Yeah, that's right. Yeah. Part of the other reason I gave you guys the hour to work is because 6th hour had the tornado drill and I knew it would screw up that whole hour. We had roughly 10 minutes of class. From Upper Yellow, we have to go to the girls' locker room. And, well, I didn't get back till, I don't know, 25 minutes or something.
I was in the gym.
Yeah, it takes 8 minutes to go down this, I timed it because I was waiting in line forever. 8 minutes to get down the stairs.
I
Well,
was
the
in
tornado.
the
The tornado could already be here.
And then it was 7 minutes I held the door for people to come out of the locker room. And then another 8 minutes to come back up the stairs, not including travel time. So it's great. It was a great tornado drill.
If there was an actual tornado, do you think a lot of people would have gotten trampled? Like running that far down the stairs?
Is that
and,
even
like-
a question?
Well, I mean, I don't think we don't usually have the types of tornadoes that happen so instantly, we would have to run there. I mean, I know some places do, we usually don't.
Do we have a lot of tornadoes here? I haven't seen one since I've been here.
No.
I mean, we have them, but there hasn't been one in our area for a bit.
Oh, okay.
When they build the expansion, there's gonna be a much larger tornado area underneath as well too, like a utility space. So it won't be so bad once the expansion's built, there'll actually be places for people to go during the tornado drills. Instead of,
When are they starting that?
starting it, no, I think it's, I can't remember if it's next school year?
I wanted to see it.
They haven't finalized anything yet. They have to get finalized. I think it's supposed to be ready for the 2026 school year.
Oh,
I thought the expansion was gonna take like a long
I
time, not
think
one
it's
year.
gonna be a red hot.
It'll take about a year and a half to build from beginning to end.
They're adding just the stuff by the field.
What is it supposed to be like another pop at least?
It'll be another pod that goes out, the front, like the activity entrance, where that is.
Oh, so wait, all that like seating and whatever, that's gone?
Well, it's more towards the grass, towards, by the black box.
Okay,
Okay.
that makes sense.
I think I know what you're talking about.
It's kind of, it'll probably sit right next to the theater somehow.
Okay, yeah.
What?
Okay. Differential equations, that was a huge, like, I always want to say tangent, but then everybody thinks I'm trying to make a pun for kelp, but got off track there. Yeah, we got off track. This entire section is about differential equations that are based off of themselves. So if you guys would like to highlight something, this phrase right here is going to come up quite often. Hi. Thanks. Not here, actually. Yeah, he's not gonna be here till later. Yep, thanks.
What's up?
You highlight what I highlighted.
Good.
So the rate of change of y is proportional to y. That phrase is actually gonna come up pretty often. Okay, let's put our Chromebooks in. Look at, Daniel even got his Chromebook away before you.
That's impressive.
Whoa, what are you doing?
He's improving.
Olivia, you should feel shame.
But I'm doing connections.
I feel like the desk moved back.
So, this phrase translates to that. anytime we have proportional, that's where the K value comes in. And the whole reason that was in the homework yesterday was to get you used to working with a K value. It represents a number, and you don't treat it like a variable. So it's a number that you will find out later when you are given numeric information, basically. So the rate of change of y is dy dx or dy dt. And then it says it's directly proportional to y. So what this is trying to say is how fast something will change will depend on how much of it you have. Let's think, I'm assuming physics, no, that's gonna say, I was gonna say the weight, have you guys done that where, you have a hole in the bottom and then the amount of the substance up above kind of determines how fast it comes out?
Yeah, something like that.
So like the weight of, like if you have a lot of weight of water, it'll help push it at a higher velocity. And as you run out of liquid, there's not much weight anymore, so it kind of slows down even though the hole is pretty much the same size.
I feel like we did that in here. Like, as an
That's like physics too, though.
Oh, yeah, good, sure. Either way, so that would be something that is just kind of an easy example of the amount of substance that's there determines the rate of change. So how fast it comes out depends on how much was there to begin with. And that's actually gonna stand for a lot of things. It's gonna represent Newton's law of cooling, it's gonna represent what is that called? Radioactive dating?
Oh, half-lives?
Yeah, like half-life, the radioactive, it is radioactive decay, but I think they usually phrase it radioactive dating.
That was half.
Well, carbon dating is where you.
They're all- yeah, they're all the same
radioactive
thing.
date,
Yeah.
Decays are half-life.
Well, they use half-life to date it.
Oh, but I don't know how they date it, I just know how it decays.
Oh, yes, that's how they date something.
Oh, okay.
So all those same topics are related, and if we integrate, come on.
Water has a half-life.
I'm getting a little worried, this thing is blacking out longer at a time.
Just takes more power from your fridge to turn on and cool your drinks.
Yeah, that didn't even turn on this time though. Yeah.
It just magically has a fish through it now.
So glad we gotta do smart boards this year.
Wait, you do?
That's sarcastic.
This is the new one this year?
This is the new one.
Oh, I thought you meant next year, you're kidding.
No, we had our previous smart boards for 13 years.
Weren't this previous smartboards functioning better than these ones? though?
Yeah. Aren't these
They're
like
different.
like TVs?
These are basically large tablets. Yeah.
It's lab lids.
Sarge has had 3 of them already.
He's got the rolling.
Yep.
When's this for?
If we integrate,
Next 2 months.
if we integrate this, it turns into this. This is pretty much identically what we had done in the homework and the notes in section, it must have been 3. I don't know why my brain's telling me 2. 2 was slope fields, so it wasn't that.
I think it was 3.
It was either 1 or 3, but we did this exact same problem, and when you integrate it, you get CE to the KT. It was when I was explaining to you where we got PERT from.
Oh,
Now, I'm positive, I believe that's the problem down there. I was gonna say, it's probably written down somewhere, the proof of it. The good thing for you, if you see this phrase written down in a problem, and they generally will specifically write that phrase in the problem on the AP test, you do not have to integrate this to get to the general solution. By them giving you this phrase, you are allowed to go straight to writing down the general solution. Now, if you want to integrate that to get this, you can, there's nothing wrong with it. Oh, yeah, I don't know, do you want me to show you how to get CEKT again?
Yes, please.
I'm
Okay.
kinda confused with the Y of the
Sure. So we are gonna take this. And we need to separate the variables first. So we would have dy over y. The k, again, we just treat as a number that's not a variable. And then this would say k dt. And when we integrate the left-hand side, that's where we ended up with the natural log of y. The right-hand side is exactly what had been set up in your homework question, where you also had k dt. Maybe it was k dx. But when you integrate a number, you just write the number before the variable. So kt plus c. And I'm gonna guess everybody in here should be able to get to that step pretty quickly, easily. Should be able to, if you've done your homework. The next step is to try to solve for y, because that is solved for y, so that's kind of our goal, is to do that. So I need to take it out of logarithm form, and you can do it both ways. You can either write e, or you just know that this is log base e, and when you take it out of log form, it turns into e to the kt plus c equals absolute value of y. Both of them give you the exact same answer.
I'm getting rid of the absolute value.
We do.
Why is C on the bottom of the top, not the, like, why is C on the bottom in the model that we got?
Well, we're not done. You're right, it is going to end up there, but we're not there. So this next step, actually directly the one you're asking about, honors. The next step is where some people get stuck if they do. And it ties back to an old property where if you multiply two of the same bases, come on. If you multiply two of the same bases, you can add their powers. So these are already added. We are going to go in reverse. And we are going to write it as e to the kt times e to the c. Well, the c value basically absorbs any kind of numeric operation until you're trying to find c, which that question came up yesterday when people were doing their homework. Once you try to find c, then it does not absorb anything. So e to the c we would actually just write as c. And then that's how come the c is down below on it. Go ahead.
For what things can we like turn into C? Like I know like 3C's it could be just written as C.
Any numeric operation on it.
Just one single one because like you can't turn E to the KT plus C to C.
Oh, just directly on C. I think I know what you're trying to ask, right. So KT is involved over there, so you can't just absorb stuff. So the only time that C can absorb things is when it's a numeric operation directly on it. Yes. We only do it for C because it's a number we're finding later. And then I can take off the absolute value, which taking off the absolute value means that we would put a plus or minus on the other side. And then since the C value is there, multiplying the C by a plus or minus does nothing. It's a number we find later anyway. So it'll either be positive or negative. So if we are given that phrase, we can go directly to this general solution and try to start finding answers. Okay. Listen. These take a lot of room. They're not terribly hard, they just take a lot of room. They're steps. It didn't turn off that time, did it?
Yeah.
It did.
Oh, okay. Ready. You wanna go or you want somebody else to go? Okay. Bob, what should I write down as soon as I read this first sentence? Because that first sentence automatically means I know the general. you're not wrong. I could write that. I'm not going to because that's more work. I can go directly to the answer because we already know what the general solution is for it.
y is equal.
You're giving me the,
Y is equal to.
there you go, there you go. You gave me the differential equation, the derivative. We can go directly to y equals ce to the kt. Okay, now, does anybody know how come c is always going to be the initial amount?
That's a constant.
Because time.
Wait,
is
am I
zero.
spelling that right? Initial?
Yeah.
Boy, that looked wrong.
Initial time is 0, so e power kt will be 1.
Perfect. As soon as time is 0, that whole thing turns to a 1, and then it would be c times 1. So the c ends up being the initial amount. This doesn't say the words initial amount, but it does say time equals 0. So if I were to put 0 in place of t and put 3 in place of y, it immediately would turn into c equals 3. So with that initial amount, I'm gonna go right to step 2. And no, Kyla, this one's actually not gonna have a terrible amount of writing, but most of the problems
I
do.
meant, like, when we were just solving for like the derivative.
They usually have a lot of space, yeah. Or they usually take up a lot of space. So we're gonna have 3e to the kt. And then our goal is to be able to figure out what k is. So we have to find two different constants within the problem. That's gonna automatically require at least 2 pieces of data to find both the constants.
I know you said C is the initial amount, but why is it the initial amount?
So if I put 0 in place of t, so initial amount means times 0. If I put 0 in place of t, this would automatically become e to the 0, which is 1. And then 1 times c would equal the initial amount answer.
Okay, so that's why you put the 3 into C and not the 2.
Oh, well, it said t equals 0, y equals 3.
Oh, okay.
Yeah, they'll phrase it either way.
I was just sorry, I looked at the T equals 3, and that's why I was confused.
At
At the bottom, at the bottom of the
second
question,
sentence.
it says.
Oh,
Yeah, sorry, that's.
yep, haven't even gotten to that part of the sentence yet. Yeah, you're right, that is actually bad planning, that should have been a different number, so that there was no confusion. So our goal here is to find both constants, and now that we have a second number set, we can figure out k. So we are going to use this number set to find k. Oops. Okay. Now I'm going to put the 6 in place of y, the 2 in place of t. Okay. I put the 2 in place of t. And this is generally the annoying step because we have to solve for something within an exponent, so that requires logarithms. And this is usually the stage of the section where we find out who does not remember logarithms and who does. And yes, we'll do the examples so you can remember them. Right, Dylan?
I don't remember logarithms whatsoever.
That was weird, then you should get off your phone, yes.
I don't remember.
So for us to solve for a power, we need to make sure that the power is the only thing on the side of the equation. That's the way to solve for a power. So I would immediately have to divide by 3. And then I believe you guys are taught to take the ln of both sides. So when I was taught it, I was taught to just put it into logarithm form. But I believe both Mr. Sullivan and Mr. Sardini, and I think Miss Flynn had you guys take ln of both sides. Only a couple people seem to remember
Can
this.
you show it and maybe I'll remember?
You guys don't remember this at all?
I was
We spent like 2 weeks on
I was a
logarithms.
sophomore when I learned this stuff.
All right.
We did ln like.
I was a sophomore when I learned this stuff too.
Well, you went through math
You
college.
use it daily.
Math college. I don't exactly know what you got your degree in.
It is.
Something math.
I'll just not add to that. Math education,
Okay. So I was right.
yes.
In different words, but yes.
Yes.
In the worst way possible, I was right then.
So when you take the ln of both sides, the reason you guys were shown to do this is because the 2k ends up being an exponent, and so that property of logarithms allows it to go out front as a multiplier. Oops, that way. So this would say 2k times ln of e. ln of e is 1, because this says e to what power is e. Go ahead.
The power comes forward and the ln multiplies to like the base number.
That is a property. A power on the inside of a logarithm can go out front as a multiplier.
Yep.
ln of e is 1, so we don't even need to write that. Then this would say 2k equals ln of 2. And then ln of 2 divided by 2 in this case would be k. We traditionally, I shouldn't say traditionally, you have the option. You are either allowed to write this as the k value, or you are allowed to change it to a decimal. If you change it to a decimal, which it seems like most everybody prefers to, if you change it to a decimal, make sure you use a lot of decimal places. Because it's in the exponent spot, and we frequently have varying sizes of numbers that we put in there, the answer changes quite a bit in accuracy with these decimals. So I don't even know how they teach sig figs, but you need a lot of decimal places for our answer to be accurate to 3 decimal places. So I have no idea how they actually teach it to you, but because it's in the exponent, it changes the accuracy a lot. Does anybody know that decimal?
3.
Actually, I take it back, I'm not gonna use it.
Probably not.
No, because it would take 5 minutes for you to list off all these decimal places. Next step, we have taken all this time to figure out the second constant. That was the whole goal of this. So we are now at the stage where we have a particular solution. It's gonna be y equals 3e, and then instead of k, you would either write the decimal or ln of 2 over 2, maybe I'll write 0.5 ln of 2 times t. Do you guys know how to use the store feature on your calculator?
Yeah.
Or the previous answer feature?
Yeah.
Previous answer is easier.
This is where it comes in handy.
Oh, yeah.
Because instead of you writing down all the decimal places of 0.5 ln of 2, you would store that decimal in your calculator or the previous answer, if it's the previous step. And then you just put that in place of 0.5 ln 2 when you calculate it.
Did you put?
Go ahead.
Okay, I was just saying to divide by 2 instead you just times it by 1.
Yeah. I gave you this calculator sheet in here yesterday, I think, right?
Yeah.
Okay, I know store is on that, so if you're not sure how to store, I can show you or you can look it up. So I've got a particular solution, and after this 4th step, then we are at the stage where we can answer the question that was asked. What is the value of y when t is 3? Because they told us t equals 0 and t equals 2, we're trying to find t equals 3. So I'm assuming, what the heck? I'm assuming the answer will be bigger than 6. Or relatively close to 6. So I am going to find the y value when t is 3 from the particular solution. And your final answer has to be accurate to 3 decimal places, and that's why I was trying to say use as many decimals as possible. I don't know if I'm going to be able to teach this in 2 days, am I? We've only done one problem. 3e to the 0.5 ln of 2 times 3.
Wait, so the 3 we're putting into C is the second question. That
It's
is-
the third part of the problem.
Okay.
They gave us 2 data points to be able to figure out the 2 constants. And then the third thing is the actual question you're trying to answer from the start. So I got 8.485.
Yeah,
That's right.
I concur.
And
Big word, it's big words.
that was good.
You using these words as like you guys.
I use big words a lot.
You've been watching Big Bang Theory live. Nice job.
What?
Big Bang Theory?
Never watched it.
You what?
Never watched it.
All right, how can you as a person who is decent at math, good at math, everybody in here should be a Big Bang Theory fan.
Yeah.
I don't know. I've never seen it. I've never seen
Put
it.
on the spot.
Oh my
I've never
goodness,
seen it.
that
I've
seems
also-
like a good assignment for you for this weekend.
Fair enough. I've also never seen SpongeBob.
That's
fair. I've
okay,
never
that's
seen
fair
it.
and that's not a problem.
I know. Or Phineas and Ferb. I can
Uh,
just watch
what?
it.
SpongeBob has
Watch it
nothing to
myself.
do with
Did
this
you
class.
watch?
Yeah. Little Einsteins, Mickey Mouse
Oh,
Clubhouse. What other ones?
Why- no, no, I was not bringing up cartoons in any
Look, he
way.
did.
I said what? Because he hasn't seen Phineas and Ferb either.
Again, I
I
don't care,
watched
I'm
it
not
on-
bringing
I
up
watched it on my
cartoons.
own. My mom didn't let me watch that.
Your mom didn't let you watch Phineas and
Or
Ferb?
SpongeBob. Or a lot of other shows.
SpongeBob makes sense, but Phineas and Ferb?
It was my fault for bringing up Big Bang Theory. You guys have to learn how to focus.
I'll go take a look at it this weekend.
Okay. Okay, bacteria in the culture is growing at a rate, it looks like they gave us an equation already.
It doesn't work though.
Per unit of time. At time equals 0, the number of bacteria is 7,500. Find the number present at t equals 5. Now, in fairness,
I know, see.
I'm gonna guess you read this a little bit ahead of time?
Yes.
Okay. First time I looked at this question, I was thinking the exact same thing as you, because like this doesn't come out to 7,500 and it doesn't really work. However, it's the phrasing of the problem that is kind of tricky. And that's where I got thrown out. So, the word growing means that that is the derivative. So we would have to integrate this
Oh,
to
wait.
find the general solution.
I hate that.
Exactly.
I thought it was gonna be easy.
So dB dt is 3,000 e to the 2/5 t. I'll just write it as 0.4 t. Well, if I integrate this, I would get. Are you guys doing pretty good? No, I should not skip steps.
Don't skip steps.
On the free response test, they will specifically give you a point for writing the variables separated. So I should never skip steps in my head with you on this. You will almost be guaranteed to get a separation of variable questions on free response somewhere. It'll be like part B of a question. And if you do, even if you're not sure how to solve the question, if you write the variables separated, that is always one of the 9 points, is them dedicating 1 point for writing the variables separated. So basically just showing that you know what to do with it, you get a point, even if you don't know how to solve it. Okay, integrate. And then integral of dB is b. And then we have 3,000 e to the 0.4 t. Who should we go with? Kravath, who are you calling on? Yeah, not one of these two, they get called on every day.
Get him, man.
Today-
Alright, Kravath, that was good humor. Matt, apparently,
Okay.
you are not called on enough.
That's
How do you remember how to integrate this?
The 3,000 would drop down as a multiple.
Okay, good, 3,000 is kind of irrelevant for the integral.
And then it would be e to the 0.4t times the derivative. Or,
So we need, if this was what you would make your u substitution, we are missing a 0.4. Whoops. Shoot. So the 3,000, you can think of it as this, right? The 3,000 is not anything for the integral. But if we have e to the u, you need du to be able to integrate. So the derivative of 0.4t would be 0.4. And by writing in a 0.4, that requires you to divide by a 0.4 out front. And yes, I changed it to a decimal at the beginning. It works the same with the fractions. So instead of using a 2/5. Conveniently, Spencer, this is 3,000 divided by 0.4 will, yeah.
Wait, I,
Go ahead.
you know, don't you have to do like a chain rule?
This 0.4 that I wrote in is the chain rule. So when you're doing integration, you have to have the chain rule there
First.
before you integrate. So if I write a 0.4 inside to make du correct, I also have to divide by 0.4 in the same problem to keep it balanced. And then I choose to do 0.4 on the inside, divide by 0.4 on the outside. So it's basically like, if I multiply by 2 and divide by 2, it's a 1. So it doesn't change the value of the problem. I can't just randomly multiply by something because it changes what it's worth. So I have to counteract it to keep it balanced. And then we just choose where to use that multipliers. I don't remember, was I supposed to solve for something?
T5.
T of 5, yeah.
So the 0 and 7,500 is there for me to figure out C, and I believe C is gonna be 0. Because if I put 0 in for here, I would get
That number.
7,500 plus C equals 7,500.
Therefore.
C is 0.
Yay, we could get rid of C. This time me forgetting it was a good thing.
Mm, let's,
Oh, you forgot C.
we should not forget it as a good thing.
Unacceptable.
And then you plug in 5.
7,500
Did I skip that part too fast? Do you want me to go over how C was 0? Is that what you're asking?
Is it because e to the 7, 5?
So if you plug in 0, 7,500, 0 would go for T, 7,500 would go for B, and then
That would be 1.
this would be 7,500 times 1 plus C equals 7,500. And then you would subtract 7,500 from both sides and C would just be 0. So C is nothing for this problem. And then I don't know what this answer is, but that's the answer.
55,000.
So, oh, because we got t 0.
Oh, that's gonna take a while. That's gonna take a long time.
What is?
Spencer trailed off, so I will just write 55,000-ish.
I took my calculator. so-
Oh, wait, hold on, it's 55.
Yeah, I already wrote the answer, we're good.
Yeah, we're
Oh,
good.
fair enough.
Yeah.
55K.
That should be-
I suppose K is probably a terrible acronym to use for this one.
No, it works.
Not work, oh, yeah.
I mean,
This one didn't have a K underneath, so.
55,000 each.
AP test 5.
Yeah, never use the ish as an answer.
5.
So if we did that on
On
the
our test,
you would
we
get
would
it
get
wrong.
a
Or
5.
wrong.
You can do it all you want, it'll just be wrong, yeah. I
Can we
mean,
do it on your test?
it'll still be wrong.
Oh.
Ish, what?
Spencer started reading the answer and then trailed off, cause somebody stole his calculator, so I just, all I heard was 55,000.
What's the right answer?
It's like 4.
55,417.921.
I was gonna say, just type it in yourself. Don't be lazy.
My calculator.
You have a calculator in front of you.
And since it's bacteria, you don't wanna have like the decimals, right? It's like pounds or whatever.
So
Fact,
that will
it's-
be
it's
up,
multiplying right now, so it's
That would
like.
be-
why are you answering her?
Oh, I'm sorry.
Shut up. What are you asking?
That will be up to what's written in the question.
So
So
then
I
you
would
use
guess,
1,000.
I would guess the question would say round to the nearest whole number.
It says find the number present, so.
So, we were given details, so you would just give a decimal. Okay, what time did we get done today? 27.
I think we can be done.
Oh, no, we're starting this even if we don't finish it because this, that is what Saturday and Sunday is for.
What?
We can walk down to the girls' locker room.
What?
What?
The
That is
tornado
the
drill.
tornado drill.
I understand, but we know we're not, we already did a tornado drill.
This, I kind of.
Okay, slow economy causes the company's annual revenues to drop from that to that. If the revenue is following an exponential pattern of decline. This is kind of iffy wording right here. I realize that wording is trying to tell us that y equals CE to the KT. I don't think they would phrase it that way on the AP test, though. They are pretty consistent on usually writing the rate of change of y is proportional to y. But I also know that that is what they are intending for this problem, I hope. So we would go right to this. And, or this is an exponential. Okay. So, when we write CE to the KT, because we're gonna use this for a ton of these questions. We immediately have two constants. We have to figure out both of those constants to be able to solve an answer. You're not always going to be given the initial amount. I definitely did not want to do one of those today. But know that Monday, we're gonna have one of these same questions, but you are just given two values that are non-initial amounts. So you can't just find C right away. Apparently it was a good idea. The initial value in this one is the 530, even though it doesn't directly say. So 2008 is going to be our time equals 0. Even though it doesn't say, we're treating that as time 0. So our initial amount is 530,000. We are gonna put that in place of C. And you can always put the numbers in to solve for C if you want. It's just more work and you don't need to. Then we go to step 2, which is right here. And that's going to be time equals 2, just because it's 2 years later. And 386,000 for Y.
Wait, why?
Y is going to be the final amount of money, starting with 530,000 for a number of years. So this one is telling us in 2 years, even though it doesn't directly say 2 years, in 2 years, the amount of money would be 386. If you wanted, I could have written R instead of Y, like for revenue or something, I don't know. Where'd it go? 530,000. E to the K times 2. And then this is a very calculator heavy section, but not difficult calculations. It's all like multiplying, dividing. Yeah, go ahead.
It's 2 because it's 2 years later, right?
Uh,
Stupid question, that's what unraised money.
So 386 divided by 530 is point. I don't want to use this big decimal.
I just put like,
Let's just write it as 386 over 530. I'm sure it reduces. I suppose I should find out.
wait, is this where we take, is this where we take the natural log of both sides?
It does reduce, but only cuts in half. Yes, we're gonna have to take the natural log of both sides to solve for the next one. So the natural log of that equals the natural log of that. 2k comes in front as a multiplier, ln of v virtually disappears because it's multiplying by 1. So we have 2k equals ln of 386 5/30. Come on, there's a dead spot in the board, here we go. If you wanna write that as a decimal, you certainly can. I don't, because there's just a lot of decimal places and this is more exact. I always prefer to try to keep it as exact as I can until we get to the final answer. And then divide by 2. So k is gonna be 0.5 ln 386 5/30. Now this is where the store button on your calculator is super convenient, so that you don't have to keep typing that in multiple times. So we figured out k. All right. So the amount of money we have is going to be 530,000 e to the 0.5 ln 386 5/30 t.
When are we gonna add the zeros back in?
What do you mean? Are you talking about for the fraction?
Yeah.
I reduced it.
Oh, I see.
You divided them both by 1,000, yeah. I think it reduced, it does, the calculator said it does reduce a bit further, you divide them both by 2, but that's it. So I'm just writing this just because I know it's correct, and it doesn't matter if I reduce it or not, I wouldn't need to have it marked correct. And then the very last thing said what, how much money would be in what year?
2013, so T
So,
equals 5.
T equals 5, okay. So T equals 5. Once you get the hang of how these are set up, it's not. What makes these very doable is they all generally start with the same equation. If they started with a different differential equation each time, it would be kind of horrible. I'll make it official. Something
Yay.
Awesome.
that you could just type in on your own because you have fingers. And I made it in time. I knew we'd fit a third problem in. Look, you guys were like trying to be lazy and
I
say
think,
it.
I
It
think.
was
No,
right
it's
time.
not just Spencer.
I think we
It
can.
was
speed
not
her
just
up.
Spencer.
I know.
It was me.
We can, but I don't wanna do number 5 because this is the one I was mentioning that doesn't have an initial amount. And needs to be solved a different way.
So you
Okay,
can actually
perfect.
adjust for it.
You could figure it out